So now this is the rig using a power tool battery to provide power to the camera as well as any other accessories via USB. This particular project isn't something new. The oldest video I have searched for on YouTube is about 14 years old. And there are several other videos which utilizes the same principles of using a power tool battery to provide power to a camera rig. The use case of this particular project is for content creation which requires long runtimes, or in instances and situations where changing a battery may not be as simple, or if a certain event cannot be interrupted. Given that most modern cameras can be powered from USB Type-C power delivery, my particular setup will utilize USB as opposed to using a DC to DC converter. One of the main reasons why I decided to go with the OZITO branded power tool batteries is because it is the most budget option in my area. The power tool battery itself also has an inbuilt battery management system in BMS, so that once it reaches a low voltage, it will automatically turn itself off. This is to prevent from the battery cells draining completely to the point where the battery itself becomes dead and is unable to be recharged correctly. This also means I do not have to install a low voltage cutoff circuit board into my design as well. One of the reasons I have chosen to use this particular USB-C panel is the voltage range that this panel can operate. As you can see, it can operate between a voltage of 10 volts all the way up to 30 volts. And what is more interesting is that this particular panel has the ability to output 48 watts maximum using both the USB-C power delivery port as well as the USB-A port. And I have also incorporated this voltmeter to give me a digital display of how much power is left in the battery. This is a 3D model I have developed in Tinkercad, and it's designed to house all the components needed for this power tool battery supply. I have designed this to be able to mount the voltmeter as well as the USB-C and USB Type-A surface panel mount, as well as the OZITO battery mount. I have also inserted holes onto the base of this model to house the rail that can mount onto 50mm rods. Okay, so here we have a few products from the OZITO brand. Here we have a battery, which is a 4-amp battery. Here we have an LED skin, and here we have a drill skin. I would advise to try and purchase this particular device. This here is the USB power source skin for the OZITO brand range. Now the reason is the ability to remove this particular adapter plate from this skin. So all you need to do is remove 4 of these bolts, and this will be removed. And that will look like this. A simple negative pin and positive pin. Now the reason why I suggest to use the power source skin is because the LED light doesn't have a removable pin adapter, neither does the drill itself. This here is the OZITO USB power source skin. Now let's pop it open. Here we have a torque bit. This is T10. And now we will open up this plate. All right, we have removed all 4 screws. Now let's pop open this red casing here. I'm just using a flat screwdriver and just wedging in between. Here we have the top cover removed from the USB power source skin, and what we need to do now is to remove the circuit board from the mounting plate. So we need to remove these prongs in order to mount them onto the plate. And what I've done is used a soldering iron to melt off these solders and remove them. This is what the plate will look like now with the attached prongs. And what I've also done is soldered on a positive cable and a negative cable to this plate. Here are all the parts for the rig. In the center, we have a 3D printed design to encompass all these parts. Here we have a voltmeter display. Here we have a USB Type-C and a USB power board. Here we have a simple on-off switch. Here is the OZITO plate with the 2 soldered wires. And on the bottom is a 15mm rails. Okay, the first thing I want to do is to install the 15mm rail to the 3D printed rig. We'll now install the battery mounting system. So we'll feed the cable through the slot and then run it up through here and then insert it through this hole. We will now use the T10 torque bit to install these screws. Okay, I have installed the mounting plate to the 3D printed rig, and just a quick test, we will now slide this battery into this rig, and we have solid contact, and now we will eject and eject. What this is, another USB power bank. That's essentially what this is. If you break it all down, is utilizing a drill battery and converting it into a power bank using these USB Type-C and USB Type-A ports. Okay, we will now crimp the positive in on this main line using this particular terminal. Right, we have crimped one terminal onto the positive input, and that will attach to this switch, and then the other terminal will be connecting to the positive of the voltmeter as well as the positive of this USB-C, USB-A power source device. So the thing that I messed up on was I didn't insert these cables prior to crimping those all the cables together. That's why I kind of freaked out. So let's now zoom in so you can kind of see this at work. So this, you can add 3 cables in. I don't know if you can bet you can just see those 3 circles. So now I can insert 1 cable in, and you have to feed it all the way through, and then we'll get another cable, feed that all the way through. Yep, so we have all 3 cables pushed all the way through. And now with a pair of pliers, clamp this down. Okay, so we need positive here, positives, and let's crimp that down. Okay, we have all items crimped and ready to be installed. First of all, I want to make sure that the switch actually works and everything powers on correctly. So we'll just install this without installing it into the rig itself. Install the battery. Let's flick it on. Right, we have a voltmeter display, and we have a power on for this USB Type-C, USB Type-A power output. Let's now attach the switch. I've installed the switch. I will now install the voltmeter LED display, And now I will install the USB power output to the top panel. Alright, let's do one more test. Alright, we have a voltmeter, we have an active power output via USB Type C and USB Type A. Let's now install the top panel. And that is it. A 3D printed case to mount a power tool battery such that we have a voltmeter display of how much voltage there is in the battery, as well as having a USB Type C power delivery and a USB Type A quick charge port as well. Okay, now we can install the battery plate to a camera cage using the 15mm rails. And now we can install the battery. And power on. I now have a dummy battery which suits into this particular camera that can be run off USB Type A. So now I can power on the camera using the dummy battery that is now connected to the USB Type A port of this battery plate. So now I have a camera that is now powered off using a power tool battery, which is then connected to a USB hub, which outputs a power into the dummy battery of this camera. I performed a runtime test using the battery and the camera. The Sony RX10 Mark II was set at XAVC S HD, 1080p 30 frames per second at 50 megabit per second recording. In total, I got roughly about 14 hours of record time internally onto the SD card. One thing to note, once the power of the power tool battery drains, it will automatically shut off the camera, which means that the recording will be incomplete and it may be possibly corrupted. Okay, so here is a cost breakdown of all the parts that was used to assemble this battery plate for the power tool battery. Most of these items were purchased from local electronic stores, so they might be cheaper if you were to purchase them online. Altogether, the cost is about $167 Australian. To conclude, this project was primarily created to reuse parts and items from around the place. I am a firm believer of having items that can be used for other purposes than its intended purpose. As can be seen in the very beginning of the video, multi-purpose, versatile, resourceful. These are the things that I truly believe in and hope to strive to create more projects based on those beliefs. I hope you have enjoyed the video. If you have any questions, please leave a comment, like and subscribe, and I'll catch you on the next one.